Hello everyone. In the previous class, we have started with the module number 4, that is behavioral modeling, and we have discussed about structured procedures. And in the structured procedures, we have discussed two statements in that is initial statement and always statement. Today we are going to discuss about the procedural assignments. We know that there are different types of data types available in the Verilog HDL, like register, integer, real, time, etc. So the procedural assignments, so this is an assignment statement. A right hand side value is going to be assigned to the left hand side, but this is called as procedural assignment. In previously we have discussed the continuous assignments. So similar to that one, here we have another kind of assignment, that is procedural assignments, in which these assignments update the values of the register, integer, real or time variables. So the procedural assignment update values of register, integer, real or time variables. So here the value placed on the variable will remain unchanged until another procedure assignment updates the variable with a different value. So here whatever the value that is already available on that particular variable, that is going to remains the same. It is not going to change unless and until you are going to assign another you are going to assign the procedural assignment with another value or with a different value. Whenever you are going to update that value with another value, then only the value of that variable will be changed. So this is not like a continuous assignment. In the continuous assignment, that is we have discussed in data flow modeling, there one assignment can cause the value of the right hand side expression to be continuously placed onto the left hand side of the net. Here, unless and until you are not going to assign the new value or a different value, the value that is already assigned to the variable will remains the same. So syntax for the simplest form of procedural assignment is shown here. So how to use the procedural assignment? See here the syntax, the variable L value. So this is the left hand side of the expression, variable L value. L value is nothing but left value, is equal to sign is used to assign the value to the left hand side variable. Then in a bracket there is a delay or event control. In bracket means it is optional. It may be present or it may not be present. That's why it is written in a bracket. It's a optional part. If you want to use a delay in your expression, you can place it by writing hash sign. So that will be act as a delay. After that particular delay, the expression will be assigned to the left hand side, followed by the expression. So expression will be present at the right hand side. So the left hand side of the procedure assignment, that is L value or left hand side value, can be one of the following. So it, as already told, it is the data type. So it can be a register, integer, real or time register variable or a memory element. It can be a variable or it can be a memory element. It can also be a bit select of these variables. Whatever the variable that you are going to select, if it is a vector type, out of that only one particular bit can be selected. That's why it can be a bit select. Also it can be a part select. Out of, for example, 12 bits, if you want to use only a 4 bits or 6 bits, that can be used here. So you have to specify the from which bit to which bit. That is a part select of these variables. The example is given here for the first as well as the second. For bit select, it is address of 0. That means 0th bit of that address. Then part select is taken as address of 31 down to 16. So 31 down to 16. Out of 31 down to 0, only a part of that is selected, 31 down to 16. And you can also use a concatenation of all the above. So you know the function concatenation. So concatenation can also be used here in the expression, left hand side value. Then the right hand side can be any expression that evaluates to a value. So here the delay can be a optional one. After that delay, you need to write an expression. What should be that expression? The expression should be at the right hand side, and it can be any expression that is evaluates to a value. Finally some value must be present. So in a behavior modeling, all the operators listed in the data flow modeling can be used in the behavioral expression. So in the behavioral modeling, the operators that are listed previously in the data flow modeling, all those can be used here. So the procedural assignments are classified into two types. The first one is the blocking assignments, and the second one is the non-blocking assignment. So today we are going to discuss the blocking assignments. First one is the blocking assignments. So blocking assignment statements are executed in the order they are specified in a sequential block. So as we have discussed in the structured procedures, initial and always, initial is a block. Initial consists of a block. So in that block, if whatever we are going to write the statements, so that can be that those are going to be executed in sequentially. So the blocking assignment statements are executed in the order they are specified in a sequential block. So sequential block means what here? So whichever the statement that is written first, that will be executed first. Whichever the statement written in the second line, that will be executed after the first statement. Whichever statement that is written at the last, that will be executed last. So one by one statements are executed. So this is nothing but a sequential execution of statement. So blocking assignment statements are executed in the order they are specified in the sequential block. So whichever order that you are going to specify in the sequential block, in that particular order only the expressions are going to execute. A blocking assignment will not block execution of statement that follow in a parallel block. So here we have two types of blocking statement. We have two types of procedural assignments. One is blocking, another one is non-blocking. So you'll understand what is the difference between blocking and non-blocking assignment operators. So here blocking assignments will not block the execution of the statements that follow in a parallel block. So here both the parallel as well as sequential block we are going to discuss in the later part of this module. So sequential and parallel block will be discussed later. The is equal to operator. The is equal to operator is used to specify blocking assignments. Remember here, this is very important. For the blocking assignment, the assignment operator is used is equal to. So here there is an example. First, let us declare few variables: reg x, y, z, reg 15 down to 0, reg a, reg b, integer count. So these are this is the declaration part. We have declared few register variables, then a count, integer count, then the initial. It is the structured procedure, a keyword. From here onwards, the sequential block begins. So begin and end is used for grouping purpose, because more than one statement is used here in the initial block. So this is in a one initial block, all the statements, all the expressions that are written here are going to execute in the order they are specified. That is nothing but blocking statements. So x equal to 0 comma y semicolon y is equal to 1 semicolon z equal to 1. So here they are separated by semicolons. That means they are each one is here expression. It is x equal to 0 is one expression, y is equal to 1 is another expression, z equal to 1 is third expression. Count is equal to 0. Reg a equal to 16 bit binary 0. This is one expression. Reg b equal to reg a. So all these are assignment statements, blocking statements. Then hash 15. Hash 15 is a delay. In the previous statements, delay is not used. So by default, the delay is 0 here. But here, in this case, the delay is 15. Hash 15, reg a of 2 is equal to 1 bit binary 1. So here it is a bit select. Then next one is the part select statement. Hash 10, it's a delay. Reg b 15 down to 13 is equal to x comma y comma z. That is concatenation of the x, y, z. Then finally count is equal to count plus 1 end. So this is a sequential block. So this is an example for the statement. So what happens here in this? In this example, the statement y is equal to 1 is executed only after x equal to 0 is executed, because x equal to 0 is written first, y is equal to 1 written after x equal to 0, then later z equal to 1 is written. As these are the blocking statements are going to be executed in the order they are specified in a sequential block. That's why first x equal to 0 will be executed, then y is equal to 1 will be executed, later z equal to 1 will be executed, even though all these statements are executed at time 0 only, because the time is delay is not specified here. Delay is not specified. By default the delay is 0, but still the order they are written, they will be executed. So x equal to 0, first 0 is assigned to x, 1 is assigned to y, and 1 is assigned to z, sequentially one after the other. Then count equal to 0 is assigned to count. So the statement y is equal to 1 is executed only after x equal to 0 is executed. So the behavior in a particular block is sequential in a begin end block if blocking statements are used. Remember here, as the blocking statement is used here, they are going to execute in an order they are written within a begin and end, because the statements can execute only in a sequence. The statement count is equal to count plus 1 is executed last here out of the first 4. Then the simulation time at which the statements are executed are as follows. So all the statements x equal to 0 through reg b is equal to reg a. Observe there, where is reg b equal to reg a. So all these do not have any time delay. That's why from x equal to 0 through reg b is equal to reg a are executed. All these statements are executed at time 0, because the delay is not specified. By default the delay is 0. Then the statement reg a of 2 is equal to 0 is executed at time 15, because the time delay provided here is 15. Then statement reg b 15 down to 13 is equal to x comma y comma z within a curly bracket. So this statement is executed at time 25, because previous statement is executed after 15 time units. So this statement is executed after 10 time units after the completion of the previous statement. That's why that total time required to start execute this statement is 25 time minutes. That's why this statement is executed after 25 time minutes. Then finally statement count is equal to count plus 1 is also executed at time 25. So here, even though the time delay is not specified, time delay is 0 here, but this statement is written last in the order. So in the previous statement is executed after 25 time minutes. So after that only this statement will be executed, because it is written in a sequential block. That's why there is a delay of 15 and 10 in the preceding statement. Count is equal to count plus 1 will be executed at time is equal to 25 units. So same is explained in this slide. So here one more thing you need to note, that the procedural assignment to register, if the right hand side has more bits than the register variable, the right hand side is truncated to match the width of the register variable. So if the right hand side has more bits than the register variable, if your register variable is only 3 bits, but if you have more than those bits, then right hand side is going to be truncated to match the width of the register variable. It will be cut down to the value that is going to be matched. So the least significant bits are selected and the most significant bits are discarded here. So the least significant bits are going to be selected, but most significant bits are discarded here. If the right hand side has the fewer bits, zeros are filled in the most significant bits of the register variable. So if it is more number of bits are there, then it is truncated. But if the right hand side, if less bits are there, then zeros are filled in the most significant bit of the register variable. Thank you for watching the video.